Okay, hello everyone. How are you today? I hope we are in a good condition today because right now we are going to learn about vector. So let's start our lesson. The first is what is vector? Vector is one of the fundamental topics in mathematics because they help us describe quantities that have both size and direction. Before learning more advanced topics such as vector operation, geometry, or physics, it is important to understand the basic concept of a vector. So, what is a vector? A vector is a quantity that has both magnitude and direction. The magnitude is the length or size of the vector, while the direction tells us where the vector points. Vectors are usually represented by an arrow. The length of the arrow represents the magnitude and the arrowhead represents the direction. For example, if two vectors point in the same direction but one arrow is longer than the other, the longer arrow has the greater magnitude. Now, let's compare vector with scalars. A scalar is a quantity that has only magnitude and no direction. Examples of scalar include mass, temperature, time, distance, and speed. A vector, however, has both magnitude and direction. Examples of a vector include displacement, velocity, force, and acceleration. This difference is very important because vectors cannot be treated in the same way as scalars. Now, let's see how vectors are represented mathematically. A vector is usually written using a bold letter such as V or with a small arrow above the letter, written as like that. In the coordinate plane, a vector is commonly written in component form as V is equal to A point B, like this, where A is the horizontal component and B is the vertical component. Another way to write the same vector is V is equal to A times I plus B times H or G, where I is the unit vector in the X direction and G is the unit vector in the Y direction. Both notation represent exactly the same vector. Now, let's understand what the components mean. Suppose we have the vector V is equal to 3.4. The first component, 3 means we move 3 units to the right along the x-axis. The second component, 4 means we move 4 units upward along the y-axis. If we draw this vector starting from the origin or the point 0.0, its endpoint will be at 3.4. The vector can also start from another point. What makes a vector unique is its magnitude and direction, not its position. Therefore, two vectors located at different places are considered equal if they have the same length and point in the same direction. Now, let's learn how to find the magnitude of a vector. The magnitude of a vector is written as like that. To calculate it, we use the Pythagorean theorem. The formula is the length of the vector V is equal to square root of a square plus b square. Let's use our previous example. If we have the vector 3.4, then the length of the vector is equal to square root of 3 square plus 4 square, which equals to 5. Therefore, the magnitude of the vector is 5 units. Now, let's discuss the direction of a vector. The direction is usually measured as the angle between the vector and the positive x-axis. The angle is denoted by theta and can be calculated using the formula theta equal to tan inverse of b divided by a. For the vector 3.4, the angle is theta is equal to tan inverse of 4 divided by 3, which is approximately 53 degrees. This angle tell us exactly where the vector points. Next, let's look at another important concept, equal vector. Two vectors are equal if they have the same magnitude and the same direction if they are drawn at different positions. For example, if one vector starts at point 0.0 and another starts at 5.2, they are still equal as long as both have the same components. We also have the zero vector. The zero vector is written as 0.0. Its magnitude is 0, so it has no direction. Now, let's briefly discuss basic vector operation. The simple operation is vector addition. To add two vectors, we simply add their corresponding components. For example, if we have vector 2.3 plus vector 4.1, so we just need to add 2 plus 4 and then 3 plus 1, so we get a vector 6.4. Similarly, vector subtraction is performed by subtracting the corresponding components. For example, if we have vector 5.6 minus a vector 2.1, so we get the vector 3.5. We can also multiply a vector by a scalar. For example, 2 times a vector 3.4, so we get the vector 6.8 because 2 times 3 is 6 and 2 times 4 is 8. Multiplying by a positive number makes the vector longer while keeping the same direction. Multiplying by a negative number changes both the magnitude and the direction, causing the vector to point in the opposite direction. Vectors are an important foundation for many areas of mathematics, including geometry, linear algebra, and calculus. They are also widely used in science and engineering. So, a vector is a quantity that has both magnitude and direction. And finally, we can perform basic operations such as addition, subtraction, and scalar multiplication. Okay, I think that's enough for me. Thank you for your attention and see you to the next video.